More applications and modeling. First, let's discuss a blueprint for problem solving. There are 4 basic steps in problem solving. Number 1 is to read the problem, and this may seem really obvious, but you want to make sure you read the entire problem and then read the problem again as you start to list the items that are known and the items that are unknown. Second step, assign a variable to one of the unknown items. In most cases, we will let x equal the item that we are looking for, but we don't have to use the variable x. Then translate the other information in the problem to expressions involving the variable that you choose. Step 3, reread the problem and then write an equation using the items and variables listed in the first 2 steps. And then the 4th step, solve the equation. And then, of course, after you solve, you will need to answer whatever question was being asked. I don't include this in the steps, but it is important that you also make sure that you're answering the question. Let's take a look at an example. So here, the length of a rectangle is 3 inches less than twice the width. The perimeter is 45 inches. Find the length and the width. Okay, so the first thing we need to do is read that question, and then now I'm going to read it again, paying attention to the important parts. So we're finding the length and width of a rectangle. Let's ask, what do we know about the length and width? So we know the length is 3 inches less than twice the width. So the length depends on the width. All right, so now I feel like we've done a pretty good job of reading the problem. Let's go to our second step. I'm going to let x represent which one, the length or the width? Well, we're going to let it represent the width, all right? Because the length depends on the width. So if we know what the width is, we should know what the length is. So if x is equal to the width, then what is the length? Well, the length is 3 inches less than twice the width. Twice the width means 2 times the width. So that's going to be 2x. And then 3 inches less than that means we are going to subtract 3 from 2x. All right, now the third step is to write an equation. What else do we know about this? Well, the perimeter of this rectangle is 45 inches. So in this problem, it's going to be helpful to know that the perimeter of a rectangle is 2 times the width plus 2 times the length. And now with this, we can write an equation. We know the perimeter is 45, and this is in inches. Everything is in inches, so I'm going to leave the units off. That's equal to 2 times the width, which is going to be 2x because the width is x, plus 2 times the length, which is 2x minus 3. And then the last step is to solve this equation. So now we're just going to distribute here. 2 times 2x, 2 times negative 3 is going to give us 4x minus 6. Combining like terms, we have 6x minus 6. And then now we're going to add 6 to both sides. This gives us 51 is equal to 6x. Finally, dividing by 6, x will be 51 divided by 6. You can reduce this. 51 is 17 times 3, and 6 is 2 times 3. So we can cancel that out. And basically, we get 17 over 2 for x. Now, you can also express this as a decimal. This would be 8.5. And now we'll go back up to the top, and we'll make sure that we answer the question. So the width, remember, that was equal to x, and we now know that x is 8.5, and that's going to be in inches. And the length is equal to 2x minus 3, so that's going to be 2 times 8.5 minus 3, and that's 14. So 14 inches. So what we have in the end is the width is 8.5 inches, and the length is 14 inches. And so that's the answer to the question. Now, you can check your answer to make sure that the perimeter is 45 inches. So remember, the perimeter is 2 times the width plus 2 times the length. And 2 times 8.5 is 17, and 2 times 14 is 28, and 17 plus 28 is indeed 45. And so it checks out. In the next problem, suppose a person invests a total of $10,000 in 2 accounts. One account earns 5% annually, and the other earns 6% annually. If the total interest earned from both accounts in a year is $560, how much is invested in each account? All right, so in a problem like this, it is often helpful to make a chart to keep track of the information because we have 2 accounts and each account has various different information and we need to have a way of organizing all of that. So if you don't know how to make a chart, just draw a box, and then I'm going to start drawing some lines across the box here to make some rows and columns. Okay, so I'll do the same thing here. And if you end up having too many rows or columns, you can always just erase them later. But in this problem, we have 2 accounts. We have a 5% account and we have a 6% account. And I'm going to put that over here to the side. And we don't have another name, so I'm just going to call it the 5% account and the 6% account. Now, what do we know about an account? Well, we're going to put money in that account. Okay, so the money that you put into an account, this is called the principal. And then each account is going to have an interest rate, and that's actually the 5% and 6%. And then each account is going to have an interest earned. Okay, so the principal is the amount of money that we're putting in each account. And we do not know how much money, but we do know that we have a total of $10,000. Now, what that means is part of the $10,000 goes in one account and the other part goes in the other account. So let's think about this. If we put X dollars in the first account, let's pretend here. Let's say, what if X is $2,000? Then how much would be put into the other account? Well, the other account would be $10,000 minus the $2,000 that you put in the first account, right? And that would be $8,000. And this would be true no matter what you put into the first account. To figure out how much you put in the other account, you have to subtract whatever you put in the first account. So if we put X dollars in the 5% account, then in the 6% account, we are going to have 10,000 minus X dollars left over for that account. Now, the interest rate, this is pretty straightforward. The interest rate, when it's 5%, we're going to represent that with a decimal, so that's 0.05, and 6% will be 0.06. Now, how about the interest earned? Now, we know the total interest earned is $560, but that's not the amount earned in each account. That's the total of both of these accounts. So for this, you have to know a formula about interest. So interest, I, is equal to principal times the interest rate times the time. So again, P is principal, R is the interest rate, and T is the time. And for this problem, we know time is equal to 1 because it does say in a year. Okay, so only 1 year. So to get the interest earned, we have to take the principal, multiply it by the interest rate, and then multiply it by time, but time is equal to 1. So for example, in 1 year in the 5% account, we are going to earn 0.05 times X. And in the 6% account, we are going to earn 0.06 times 10,000 minus X. And I think I might need a little more space in this spot to write that down. Okay, so we have 0.06 multiplied by 10,000 minus X. So now we have a variable expression that represents the amount of interest earned in each separate account. And we know the total interest is $560. So the interest earned here, which is 0.05x, plus the interest earned here, which is 0.06 times 10,000 minus x, must be equal to the total interest earned in 1 year, which is $560. And now we can solve for x. So to solve for x, we're going to distribute here. So that gives us 0.05x plus 0.06 times 10,000, that's going to be 600. And then minus 0.06 times x is 0.06x. And this is equal to 560. Combine like terms, 0.05x take away 0.06x is negative 0.01x plus 600 equals 560. Then we'll subtract 600 from both sides. And this gives us 0.01x is equal to negative 40. And then our final step, we're going to divide by negative 0.01. And negative 40 divided by negative 0.01 is actually 4,000. So we now know that x is 4,000, and this is going to be dollars. But that's not the answer to the question, right? The question is, how much is invested in each account? So I'm just going to summarize the answer over here. So if x is 4,000, that means in the 5% account, we've invested 4,000. And in the 6% account, we've invested 10,000 minus 4,000, which is 6,000. So $4,000 invested at 5%, $6,000 invested at 6%. In the next example, the lengths of three sides of a right triangle are given by three consecutive integers. Find the lengths of the three sides. Okay, so in a problem where you can draw a picture, it is sometimes beneficial to draw that picture. Now, I didn't draw a picture for the rectangle problem earlier, but that was because we had a formula for representing the perimeter of a rectangle. In this case, I may not know that formula right away, so I'm going to draw a picture of a triangle, a right triangle, in fact, to help me think about the relationships in a right triangle. So let's say we have a right triangle and the sides of the right triangle are A, B, and C. One thing we know is the Pythagorean theorem, which says a squared plus b squared must be equal to c squared. All right, now in our right triangle, it says the three sides are given by three consecutive integers. Now let's think about this. If you have consecutive integers, what could these sides possibly be, right? Well, they could be, for example, 10, 11, 12, right? That's three consecutive integers. Or it could be 7, 8, and 9. That would be three consecutive integers. The problem is we don't know what the three consecutive integers are. So what we should need to notice about three consecutive integers is whatever the first number is, the next integer is just going to be one more than that, right? So 8 is one more than 7. And then the one after that is going to be two more than the original. Same thing is true here with 10, 11, and 12. So what I'm going to do is say my first side of the triangle, which I'm calling A, is x, right? I don't know what x is. B is going to be a consecutive integer, so it has to be x plus 1, and C has to be the next consecutive integer, which has to be x plus 2. And full disclosure here, C we know has to be the longest because C is the hypotenuse here. C has to be bigger than A and B. So however I define these, I know C has to be the largest one. Okay, it doesn't really matter what we call A and B here. We could switch these, but C has to be the biggest. So I've defined a variable that represents each of the three sides of the triangle by using that variable. Now I'm just going to take these quantities and plug them into the Pythagorean theorem. So a squared becomes x squared. B squared becomes x plus 1 quantity squared. And c squared becomes x plus 2 quantity squared. And now we just need to solve for x. So we have x squared plus x plus 1 times x plus 1 equals x plus 2 times x plus 2. That's just, definition of squaring. And now I'm going to multiply this out. So I'm going to use the FOIL procedure, and I won't show all the details here, but we should get that. And then we'll use the FOIL procedure here as well. And now I'm just going to combine like terms. So x squared plus x squared is 2x squared. On the other side, there's nothing to combine. And now we need to recognize that this is a quadratic equation. And the way we solve quadratic equations is we set them equal to 0. So I am going to subtract everything from one side of the equation, right, to make it 0. And then, of course, I have to subtract the same thing from the other side of the equation. So when I do this, I'm going to get 0 over here. And then here I get 1x squared minus 2x minus 3. And now we have a very simple quadratic equation that we can solve by factoring. And then setting each of these factors equal to 0 gives us two possible solutions. Either x is equal to 3 or x is equal to -1. But remember, x represents the side of a triangle, right? X represents side A. The side of a triangle cannot be negative. So we get rid of that solution. So we now know that x must be 3. Therefore, A, B, and C are going to be 3, 4, and 5. Our next example involves rate, time, and distance. So before we start this problem, let's remember that the distance traveled is equal to the rate multiplied by the time, right? So D is equal to distance, R is equal to rate, which you can think of as, speed, and T is equal to time. Okay, so it says two families from the same neighborhood plan a ski trip together. The first family is driving a newer vehicle and makes the 455-mile trip at a speed 5 miles per hour faster than the second family, who is traveling in an older vehicle. The second family takes half an hour longer, right, because they're driving slower. What are the speeds of the two families? So again, let's make a chart. We have two families. They didn't tell us anything about the families except that one family is driving faster in a newer car and the other family is driving slower in an older car. So I'm just going to label it faster and slower. All right, now each one of these is going to have a rate, a time, and a distance. Now, the faster family is traveling 5 miles per hour faster, and we are being asked to find the speeds or the rates of both families. So this is where I want to define our variables. So I'm going to say the slower family is going x miles per hour, and then the faster family would simply be traveling x plus 5 miles per hour. They are both going from the same place to the same place, so they are both going to travel the same distance, which is 455 miles. And then the time is where we don't really know, right? The time is kind of like the speed. We only know that the second family takes half an hour longer to make the trip. Now, it's tempting to want to put something in here that shows that one is a half an hour longer than the other. But let's instead use this equation to get this last box. This is the tricky part of the problem. So if distance is equal to rate times time, what would time be equal to? Well, what we can do here is we can divide both sides here by the rate, and the rate will cancel out here, and we end up getting time is equal to distance divided by rate. So this means if you know the distance and you know the rate, you can find the time. So looking at the faster family, do we know their distance? Yes. Do we know their rate? Well, we don't know their rate, but we have an expression for their rate. So we can say the time for the faster family is 455 divided by x plus 5. And likewise, the time for the slower family is going to be 455 divided by x, right? Same concept. And now what we're going to do is express that one of these times is a half an hour more, right? A half an hour longer than the other time. Well, the slower family takes longer, okay? So in terms of time, let's think about this. The slower family is going to be equal to the time for the faster family plus 1/2, right? So however long the faster family takes to get to this place, the slower family is going to take 1/2 hour longer. So the slower family, which is 455 divided by x, must be equal to the time of the faster family, which is 455 divided by x plus 5, plus 1/2. Okay? So this is the equation that we now have to solve. So to solve this equation, the least common denominator is going to be 2 times x plus 5. So we need to multiply both sides of this equation times 2 times x plus 5. What happens on the left-hand side is the x's cancel out, and we end up getting 2 times 455 times x plus 5. On the other side, when we multiply out here, the x plus 5 cancels out, and we get 455 times 2x. Plus, and then here the 2 cancels out, and we get 1 times x plus 5, which is x times x plus 5. Now let's go ahead and do the math here. 2 times 455 is 910 times x plus 5 equals, same thing here. This is going to be 910 times x plus x times x plus 5. Now we'll distribute. This gives us 910 times x plus, what's 5 times 910? Well, 10 times 910 is 9,100. So if we divide that by 2, we're going to get 4,550. Then we have 910x on the other side, and then plus x squared plus 5x. All right, one nice thing about this, when I subtract 910x from both sides, this cancels out. And when we subtract 4,550 from both sides, we end up getting 0 equals x squared plus 5x minus 4,550. So now we just have to solve this equation. Now, this equation is not really easy to solve because, if you're factoring, it's kind of hard to know what the factors of this number would be. So to do this, I think I would probably just rely on the quadratic formula. So the quadratic formula says we get -5, plus or minus the square root of 5 squared minus 4 times 1 times negative 4550, all divided by 2 times 1. And this is the square root of 25 plus 4 times 4550, and that number ends up being 18,255. 225. And then divided by 2. Now, what's the square root of that number? Well, maybe we'll get lucky. Yes, we do. The square root of 18,225 is 135. So we have two possible answers. We have -5 plus 135 divided by 2, which is 65. Or we have -5 minus 135 divided by 2, which is -70. We reject this answer because the speed has to be a positive number, so x must be 65. So what are the speeds of the two families? Well, if x is 65, that means the slower family is going 65 miles per hour, and the fast family, or the faster family, must be driving 65 plus 5, which is 70 miles per hour. In our final example, an inlet pipe can fill a pool in 10 hours, while the drain can empty it in 12 hours. Okay, so if we're just putting water in this pool from empty, it takes 10 hours to fill it up. And if the pool is completely full, it takes 12 hours to empty the pool. If the pool is empty and both the inlet pipe and the drain pipe are open, how long will it take to fill the pool? So as water is coming in, some water is also going out. Now, it takes more time to empty the pool, so that means less water is coming out than going in. So the pool will get filled eventually, but how long will it take? Okay, there's a couple of different ways to approach this. I like this approach. So I'm going to make a table, and we're going to represent the two pipes, right? So one pipe is going in the pool, and one is going out of the pool. So we have water going in and water going out. And then we have the time that it takes. So if the pool is empty, it takes 10 hours to fill it up. And if the pool is full, it takes 12 hours to drain it. Now from these, we are going to get a rate. Now a rate is going to be how much is done in 1 hour. So think about filling up a pool. If you're filling up a pool and it takes 10 hours to do it, then that means every hour you are filling up 1/10 of the pool. We simply take the reciprocal of this number. So the reciprocal of 10 is 1/10. And if it takes you 12 hours to empty a pool that's full, then every hour you would be emptying 1/12 of the pool. Okay? Now the question is, what is happening if both of these are on at the same time? All right, so we have our inlet pipe, we have our outlet pipe, and then now we're going to have both together. How long does it take to fill the pool? Well, we don't know, so we're going to call it T hours. And then how much is filling up the pool every hour if it takes T hours for both of these working at the same time? Well, it's the same concept. It's going to be 1/T. All right. So the amount of water going in the pool per hour is 1/T when they're both working at the same time. But we know that this quantity has to be the amount going in minus the amount coming out. So we know that 1/T must be equal to 1/10 minus 1/12. Okay, this is the concept. Now we just have to solve for T. So the common denominator here, well, the least common denominator between 10 and 12 is 60. And then we also have a T. So we're going to multiply both sides by 60T, just like this. On the right-hand side, the T's cancel out, and we just get 60. On the left-hand side, we're going to multiply here. And we have 1/10 times 60 is 6 times T. So that's going to be 6T minus, and then we're going to multiply here as well. 1/12 times 60 is 5, and then also times T. And this is going to actually just be T. We get kind of lucky here. And T is 60. So that means it's going to take 60 hours to fill the pool, right? And that kind of makes sense because when you leave both of these pipes open, you're putting more water in the pool than you're taking out, but these two quantities are not that different from each other. So even though you're putting more water in, there's still a lot of water coming out, which means it's going to take a long time for the pool to fill up. So of course you wouldn't want to do this in the real world, right? Okay. And that concludes this video lesson.